Hi, and welcome to lesson 15.2, the independent practice on scientific notation with positive powers of 10. And in here, we have um with estimated weight for dinosaurs. Okay, so we need to express all these in scientific notation. That shouldn't be so bad. That's 2.2. Right? You put the decimal there, move the decimal 1, 2, 3, 4, 5. So it's 2.2 times 10 to the fifth. Oh, I was looking at the wrong animal. Hello. That's 6.6. Yeah, that's this one. I was mentioning that one. So this one's 6.6. So put the decimal in between and count 1, 2, 3, 4. Okay. And so the other one, I was just times 2, 10 to the fifth. Okay, I'm going to make this a little bit bigger. Let's see, Brachiosaurus. That's going to be 1. And you don't have to put 1.0, I don't think. So 1 times 10 to the 1, 2, 3, 4, 5 times 10 to the fifth. So, yeah, 1 times 10 to the, and Camarasaurus, here it is. That one is 4. Create a number between 1 and 10 using a decimal. 4 times 10 to the 1, 2, 3, 4. 4 times 10 to the fourth. And Cetiosaurus, okay. That's 1 point. So right there, put the decimal point right there. 1.9850 times 10 to the 1, 2, 3, 4 times 10 to the fourth. There we go. And the last one is uh, Diplodocus. Okay. That's 5. Put the decimal right there. So you have a number between 1 and 10. 5 times 10 to the 1, 2, 3, 4. And there we go. 10 to the fourth. Okay. Number 2. A single little brown bat can eat up to 100 mosquitoes in a single hour. Express in scientific notation how many mosquitoes a little brown bat might eat in 10.5 hours. Okay. So it'd be this times 10.5. Let's see. 1,000 times 10.5. Well, if you multiply by 1,000, you end up moving the decimal to the right. 1, 2, 3. Yeah. hmm So that's equal to 10500. Write that in scientific notation. That would be 1.05. And then I put the decimal here, but it belongs 1, 2, 3, 4 times 10 to the fourth. Let's see how I did. There we go. 1.05 times 10 to the fourth. And Samuel can type nearly 40 words per minute. Use this information to find the number of hours it would take him to type 2.6 times 10 to the fifth words. Well, I'm thinking that if it's 2.6 times 10 to the fifth divided by 40, that means I have 6. Yeah, what? 2.6 times 10 to the fifth. So it's 1, 2, 3, 4, 5. That means I have 4 zeros. So it's 2, 6, 2, 3, 4 divided by 40. And the nice thing about this is I can cancel out these zeros. So it's really 2, 6, 0, 0, 0 divided by 4. And 4 goes into 26. 4 times 6, and then a 5. Uh, so 4 doesn't go into that. It goes into 26 6 times. It's 205, and then there's 2 zeros. So it looks like it's 6,500, right, in scientific notation. Okay, so 6.5. Yeah, put the decimal there, and I have to move it 1, 2, 3, so 3 times 10 to the third power. 6.5 times 10 to the third power. Let's see how good I did. Let's see. So if I take that and divide by 60, so perhaps what I need to do instead is I need to know how many hours. So that's words per minute, and words per hour. I would then take 6500 divide by 60, and that's 650. Come on, why am I writing so small? 650 divided by 6, which is 1, 0, 8. I'm trying to do this in my head, and I'm having a little bit of trouble. So it's 1, 0, 8, 48, 2, so 108 and 2, 6, which is 108 and 1/3 hours. And I think that's what they got here. Yeah, 108 and a third hours. So there you go. That was a pretty good problem. Next, eptomology. Eptomology, a tropical series of mite named Archegozets longicetus, Latin, I guess, is the record holder for the strongest insect in the world. It can lift up to that many times, 1.182 times 10 to the third times its own weight. If you were as strong as an insect, explain how you could find how many pounds you could lift. Well, this is what we would do. Write standard notation, and then multiply that by your weight. Okay. Complete the calculation to find how you could lift, how much you could lift in pounds if you were as strong as that insect. Express your answer in both sides. So these answers are going to vary, but if you well, let's see. This would be the case if you weighed somewhere around 80 pounds or something like that. Let's say you weigh 100 pounds. That would be pretty easy. It would be, if you weighed 100 pounds, it would be 100 times 1182, which is 118200. And that is equal to, oh boy. And that is equal, okay. I keep doing the same stupid mistake. That is equal to 1.182 times 10 to the 1, 2, 3, 4, 5, fifth. So, you can get a couple of different answers depending on how much you weigh. During a discussion in science class, Sharon learns that at birth, an elephant weighs around 230 pounds. In 4 herds of elephants tracked by conservationists, about 20 calves were born during the summer, and scientific notation express approximately how much the calves weighed all together. Okay, so I would multiply these two together. 230 times 20. 230 times 2 is 460. So I think that if I multiplied 230 times 20, that would be 460 with another 0. Okay, and then scientific notation would be 4.6 times 10 to the third. Let's see how bad I did. There you go. 4.6 times 10 to the third. And which of the following numbers are written in scientific notation? Well, this one's not, because this is not a number between 1 and 10. starting from 1 to 10. This one, that one's good. This one's good. And I'm eyeing this right here, 9.9 to 4.38. Those are all numbers, and you have to look at that and make sure that it's a number from 1 to 10. Okay, that is all there is. So all of them except for, yeah, let's see. 9.99, 4.38 times. Oh, I made a mistake. I spoke too soon. Yeah. Hello. That has to be times 10 to something. That base has to be 10. Yikes. Made that mistake. Okay, so I gotta erase that part right there. Boom. All right. And we have more here. Yay. Uh, so in this question, explain the error. Polly's parents' car weighs about 3,500 pounds. Samantha, Esther, and Polly each wrote the weight of the car in scientific notation. Polly wrote this. Samantha wrote that. Esther wrote that. Which of the girls, if any, is correct? Well, that's not a number between 1 and 10. That one's not going from 1 to 10. It's smaller than 1. I believe it's just Esther. But yes, this is in scientific notation, but is this equal to that right there? Because here it's times 10 to the 1, 2, 3. That exponent should have been 3, not 4. So it looks like none of them wrote that car, the weight of that car in scientific notation. And to explain that, here we go. So, yeah, the decimal points are the wrong place for each of these. That needs to be 3.5. And Esther moved the decimal point, right, but wrote the power of 10 wrong. That should have been a 3. Okay, justify your reasoning. If you're a biologist counting very large numbers of cells as each part of your research, give several reasons why you might prefer to record your cell counts in 17. Well, the numbers are just going to be so large, I would imagine. And it's easier to read, okay, and used by scientists everywhere, and it's easier to compare sizes of large numbers. Yeah, great. Which measurement would be least likely to be written in scientific notation? So let's see. The number of stars in a galaxy? That would be scientific notation because you got a huge number. The number of grains of sand on the beach? Yeah, that's a huge number. Speed of a car? We could deal with standard notation. It's just a couple of digits. Population of a country? Yeah, that would be that. So I'd say the speed of a car is the least likely. Uh, so here, least likely because it's a 2-digit number, like I said. Okay. So analyze relationships, compare the two numbers to find which is greater. Explain how you can compare them without writing them in standard notation first. Well, I know this one's bigger right here because I look at that exponent of 8, and that's 2 powers of 10 bigger than that one, which means this is 100 times bigger than this one. Yeah, that's the exponent. It tells you right there. And just to let you know real quick, 4.5 times 10 to the 6 is 4, 5, and then there's 5 zeros. 1, 2, 3, 4, 5. And then 2.1, well, that's going to be 7 zeros. 1, 2, 3, 4, 5, 6, 7, 1, 2. See how much bigger that other number is. Even though the digit is a 2, it has 2 more powers of 10. So it's a much larger number. And 31, or last one. To determine whether a number is written in scientific notation, what test can you apply to the first factor and what test can you apply to the second factor? Well, this is what you can do. The first factor is greater than or equal to 1 and less than 10, and the second factor is a power of 10. So let me explain what that means. If you have 7.6 times 10 to the third, this is called a factor. And that's what happens when you multiply two things. You have a factor, and that's another factor. So they're saying the first factor has to be equal to 1 and less than 10, which it is right here. And the second factor has to be a power of 10. So that's what's happening with that. All right, so that's what you got to know about scientific notation. Positive powers of 10. Next, you're going to be scientific notation with negative powers of 10. Thanks for watching.